So hi guys, welcome to Geomania. So in this video, we are actually talking about the igneous petrology and it is the second part. The first part I have uploaded before, so do check the description box or the playlist. So I suggest you to watch the part 1 of igneous petrology. So in this part 2, I am going mostly based upon the bit more conceptual part like the crystallization.
So now we are looking into the Bowens reaction series. So it is an important part in igneous petrology. So we could understand the order in which the minerals is being crystallized in an igneous rock from the magma. So now we are looking into the Bowens reaction series. So what is Bowens reaction series? It is a series which denotes the order in which minerals crystallizes in an igneous rock. As we know, different minerals constituting an igneous rock would have different crystallizing temperature. So Bowens reaction is used for this thing. So the second thing coming here is that there are two pathways. So Bowens reaction has two pathways. One is the continuous series and the second one is the discontinuous series. So here schematic representation of the Bowen series is given. So the left hand side has the discontinuous series and the right hand side has the continuous series. And both of this merges together and forms a residual series which has quartz, muscovite and potassium feldspar. Then what we have to tell is that there is olivine, pyroxene, amphibole and biotite in the discontinuous series, and also there is a calcium rich plagioclase and sodium rich plagioclase coming in the continuous series. And the temperature is given in the left hand side, that is from 1280 to an decreasing order to 650 degrees Celsius. That is the temperature range. And in the right hand side, the types of magma, that is mafic, intermediate, felsic is given. So what happens in the discontinuous series, that we have to look. First, in olivine, the olivine crystal will be crystallizing in a high temperature, say 1280 degrees Celsius. So, as the temperature is lowering, the olivine crystals become unstable, and this unstable crystal react with the magma. What? The silica in the magma reacts with the silica in magma and forms pyroxene, which has a different texture, and then it forms the amphibole. So pyroxene will be having different silicate structures, say chain structure, then amphibole will be having double chain structure, biotite sheet silicate structure, and the quartz will be having nesosilicate structure. So this is what happening, different composition and different silicate structure. So both this olivine and pyroxene and amphibole could be called as a pair. So it can be called as a reaction pair. Both this olivine, pyroxene, amphibole biotite. So that is reaction pair in this series. So then we looking into the continuous series, there is no in between composition. There is 100% plagioclase variation in, that is 100% calcium of plagioclase or 100% sodium rich plagioclase, that is albite and anorthite. And this is the Bowens reaction. So now we are getting into the some of the basics that we have to keep in mind before getting into deeper into the topic. So now we are talking about the magma. There are three types of magma: mafic, intermediate, and the felsic. So talking about the mafic or basaltic one, it has a composition that is rich in magnesium and iron and low in silica content. So there are two volcanic and plutonic rock formed from this magma, and the volcanic rock is basalt that is formed in low temperature and pressure condition, and the second one, the plutonic one, so it is type of rock that is formed in high pressure and temperature condition, so that is gabbro. Both will be having same composition. The chemical composition is given, temperature is really high, that is 1000 to 1200 degrees Celsius, and the viscosity is given as low, and the gas content will be also low. So here, as the viscosity is low, it will be forming shield type volcanoes, because from the explosion will be most like a calm one or not that explosive type, and the lava will be flowing or covering large area. So that is the kind of caused by the low viscosity, and it can bring a large area of volcanic eruption to a large square area. So this is the shield volcano that is formed by the basaltic or mafic lava. Then comes the intermediate or andesitic magma type. So the rock formed volcanic type is the andesite, and the plutonic type is the diorite. Chemical composition given, and the temperature ranges from 800 to 1000 degrees Celsius. Viscosity is also intermediate. Gas content is also intermediate. Then comes the felsic or rhyolitic magma, and hence the volcanic rock is rhyolite. Plutonic granite composition given, temperature is really low, 650 to 800, and the viscosity apart from mafic it is really high, and the gas content is also high. It traps large amount of gas in it. And here the mountains or landforms formed is mostly coniferous, like it will be having steep slopes, and as because of the high viscosity is it, the explosion will be of high amount of explosive nature and sound that will be flowing, not so more amount of land. That is not possible as the viscosity is high. So what happens is that the magma flowing will be accumulated. So magma flowing will be accumulated in the landform layer after layer. So it will be having what, a steep kind of structure. That is what happens in the rhyolitic or felsic type of magma. That is, layer after layer the magma would accumulate and forms like a steep structure. So this is the magma types, and we have to keep in mind, and this is the shield type, or which is formed by the mafic or basaltic magma, as it would be flowing to a large extent. So it will be having a steep slope, but the other would be having what, a coniferous type of slope. So this is the landforms, different kind of landforms caused by the what, mafic. So it will be having a cone like structure. So these are the two kinds of structures or difference caused by the magma type. So now we are getting into the common minerals that is found in igneous rock. We have studied that different kinds of minerals can be formed or found in the igneous rock, and it is formed at different crystallizing temperature. So here olivine, pyroxene, amphibola, mica and feldspar are given, and they are groups, and the minerals coming under these groups are also given. So other than this, many more minerals and groups are also found. So olivine will be having the highest temperature, crystallizing temperature, and from that to down the temperature would be decreasing. So this is all about the basic things that we have to keep in mind before we move on to system like concept. Now we are getting into the basics of the study of system of igneous petrology. So from here we could start from the basics. So this magma has two components, say A and B, and mostly magma will be having different, more than two or three kinds of component. For here A and B, two components. And then what happens, A will be having 50 percentage of composition, and B will be having 50 percentage in the magma. That is, A and B will be of equal amounts, A and B components. So A will be having a particular crystallizing temperature, a temperature where it starts crystallizing, and B will be also having a temperature. Maybe A will be having a higher temperature. For our instance, we could take 1200 degrees Celsius is given here. So that is the highest temperature in which A, that is the green crystal, could be told as the A, and brown one the B. So A will start crystallizing on 1200 degrees Celsius, and it will be completely crystallizing at sometimes the 1000 like that, and the brown one, that is the B, will be start crystallizing in the 1000 degrees Celsius, and it would go and complete till the 600 degrees Celsius. So this is what happens. Sometimes what happens is that the previously crystallized A or B crystals at lower temperature may react or become unstable and react with the other components in magma and may form different kinds of crystals with new composition. So now what happens is that this is the one which brings the idea of system. That is what happens, the component A and B given 50 percentage is changed. That is A is given as 60 percentage. The A is given as 60 percentage and B is given as 40 percentage. So it is told that our both A and B crystallizes at 6 degrees Celsius and it becomes a rock, a stable state. So what happens when the composition or the amount of A and B is changed? That is the composition of the magma is changed. So this variation could be explained by the concept of system. So this variation in temperature, that is melting point, can be explained, that is by the difference in composition, by the concept of system in igneous petrology, which could be explained in the coming video. So do watch the next video too.